Okay, for the second part of our Lecture 7 notes, we are going to talk about symmetry, and that will be symmetry with respect to the x-axis, y-axis, and the origin. Okay, so first one here, we have a cool-looking function that is symmetric with respect to the x-axis. Now, we will revisit this again when we get to, I think it's Lecture 9 or Lecture 10, okay, talking about our symmetry. But when you're dealing with symmetry with your x-axis, your x values will end up being the same. Okay, the x values are the same. The difference comes with your y's, where your y value is the same as its opposite, so a negative y value here. For this lesson here, I just simply need you guys to be able to look at a function and tell me, is that function symmetric with respect to the x-axis? So say we had a function that looked like this here, okay? Is that function symmetric with respect to the x-axis? Some of you are probably saying no because it's a little shaky there, but yes, that would be a function that is symmetric with respect to the x-axis, okay? Next one that we're going to look at is symmetric with respect to the y-axis. Again, we will revisit this when we get to exam 3. You guys will discover that this is something that is called an even function. Okay, so this one basically says that your y value will be the same. However, your x's are their opposite. So x is the same as your negative x. But again, for this here, I really just need you guys to be able to look at a picture and tell me, hey, if I fold this over the y-axis, is it going to match up on both sides? So something like this, for example, yes, that would be symmetric with respect to the y-axis. So this test, when you're doing this, it's just purely visual. We will get to the algebraic side of it in exam 3. Now, next one, respect to the origin. Okay, this one is a little bit trickier. Basically on this one, it is saying that if my x is positive, the negative x is on the graph, and if my y is positive, the negative y is on this graph. Now, this one is not as simple as, hey, I'm going to flip this one way. It's not like you flip it over this line here, okay? What you're going to do to prove that this is symmetric is you're going to prove, hey, if I flip this thing down, okay, so I flip this down, and then I flip it over, does it match up? Which again, if I could draw a little bit better, you would say yes. If I flipped that part of it down and that part of it over, it would match up. And that is going to be something that is symmetric with respect to the origin. Okay, so again, all this stuff is this visual, x-axis, y-axis, origin. Okay, let's practice a few of them here. Okay, this one over here on the left. Okay, is this symmetric with respect to the x-axis? Well, no. If I flipped this part up, it would not match. So that is not symmetric with respect to the x-axis. Okay. Is it symmetric with respect to the y-axis? If I flip this part over here, does it match up? No, it does not match up. Okay. Now, is it symmetric with respect to the origin? Well, let's say that I flipped this here. Okay. If I flip this here, it would look like that. And then if I flip this here, would that match up? Yes. So this is symmetric with respect to the origin. Okay. So this example here is symmetric with respect to the origin. Okay. The one on the right. Is this symmetric with respect to the x-axis? If I flip what's down low here up top, does that match up? Yes. So it is symmetric with respect to the x-axis. Is that symmetric with respect to the y-axis? Nope. If I flipped what was over here over to this side, nope. Origin, if I flip this down and then flipped it over, does it match up? Nope. So this one is only symmetric with respect to the x-axis. Okay. There are 6 more of these. So what I would like you guys to do is I would like you to pause the video, write down if you think it's symmetric with respect to the origin, if it's symmetric with respect to the x-axis, or with the y-axis on this 6. So go ahead and pause your video, try those on your own. Okay, let's go ahead and check, see how you guys did. This one here, if I flipped this puppy down, okay, I'd be looking like this, and then if I flipped it over, yep, so that is symmetric with respect to the origin. Okay, is it symmetric with respect to the x-axis or the y-axis? Well, y-axis, nope, doesn't match up. X-axis, no, it doesn't match up. So it's just symmetric with respect to the origin. Okay, one over here on the left. I can say that this one is symmetric with respect to the y-axis. If I had what was over here and I flipped it over, it would match up. Not x-axis, not origin. Next two. This circle, is that symmetric with respect to the x-axis? Notice where the x-axis is. That x-axis is right up top here. Okay, so if I flipped it over that, no, because there's nothing up there. Not symmetric with respect to the x-axis. Not symmetric with respect to the origin. Okay, because again, I'd have to flip up and then flip over, but there's not even anything up there. Okay. This is, however, symmetric with respect to the y-axis. Okay. So there's an example of one that is symmetric with respect to the y-axis. All right, on this one here, notice here's my y-axis here. And I don't know if you guys remember this, but this is a logarithm function. We will go over that second semester. Okay, that is not symmetric with respect to the x-axis. If I flip down, they don't match up. There's also nothing over there to the left. Okay, so if I flip that over, nothing's going to match up. If I flip this down and then I flip it over, again, there's nothing even over there. So this one is not symmetric at all. And that is possible. Not all functions are symmetric. Okay, so this example here with our logarithm, not symmetric at all. There's no symmetry in that function. Two more here. We've got another circle. Notice where the x and y axis are. Here's your y. Here's your x. Okay, circle is not symmetric with the y as far as this goes. Not symmetric with the origin as far as this goes. But you could see if you had this piece up here and you flipped it down, it does match up. So this is symmetric with respect to the x-axis. Now this last one here is kind of a tricky one. Okay, is it symmetric with respect to the y-axis? Yes. Is it symmetric with respect to the x-axis? Yes. If I look at this piece up here and I flip it down and then I flip it over, does that match up? Absolutely it does. So not only can you have functions where it is symmetric, where it's not symmetric at all, you can also have functions where there is plenty of symmetry in it. So for example, this one is symmetric with respect to the x-axis, the y-axis, and the origin. It is symmetric with all three of them. Okay. When you guys get to class next time, we'll do these homework problems here. You'll be finding x and y intercepts, and then we will also be talking about symmetry.